We'll make a start for the final session of the day, and it's a real pleasure to introduce Maria Cuellar. That might not be a good pronunciation, from Carnegie Mellon. Shaken Baby Syndrome and on trial.
Great, thanks so much. Hi everyone, thank you so much for inviting me. It's a pleasure to be here. It's my first time in the UK. I'm a doctoral student at Carnegie Mellon University, and I'm doing a program that's joint between the Statistics Department and the Public Policy School. I work with Steve Feinberg, and yeah, so I'll be talking about Shaken Baby Syndrome. This is the beginning of my dissertation, which am just starting now, combined with a project I was doing last year. So I have a few sections that I would love to get feedback on. If you have any kind of questions or criticisms or anything that you would like to add or you think would be a good direction to move into, I would love to hear that. And I will be drawing on some of the research by Phil David, actually, and Bill Thompson, and a few other people in the room, so I would love to hear your feedback about that. Okay, so I'm going to start talking about a specific trial of a nanny from Virginia, who's originally from Peru, and her name is Trudy Munoz. Then I'll talk about a little bit of the historical background about Shaken Baby Syndrome, and then I'm going to mention two problems that I see with the research in Shaken Baby Syndrome, and I will talk about them as they relate to an example of a specific paper within the literature. The first problem is asking the wrong causal questions, and then the second one is about bias and contextual bias. So all up to here, I've thought about for some time. The latest piece, the one about the Bayes net, is something I would love to hear feedback about. Okay, so Trudy Munoz, she was a nanny, and she was taking care of a 4-month-old baby in her home, and she had sort of a daycare center, and all of a sudden, according to her, the baby, Noah, that's his name, he started being very unresponsive, and his eyes rolled back into his head, and he was not behaving normally. And she was a nanny for many years, so she knew this is very unusual. I think he's very sick. I'm going to call 911. So the paramedics showed up, and they took this is Noah and Trudy to the hospital, to the emergency room. And right away, the physicians, they performed a few tests. So they did an ophthalmoscopy to see whether there was anything wrong with the retinas of the child, and they did a CAT scan, a CT scan, and MRI to see if there was anything wrong with his head. And indeed, they found these 3 symptoms. They found there was retinal bleeding, there was brain swelling, and there was bleeding outside the brain, subdural hematoma. And so these 3 symptoms, they're usually called the triad of symptoms, and they're characteristic of Shaken Baby Syndrome. So the police came and they asked Trudy that same day, did you shake Noah? Did you shake the baby? And she said, no, I didn't at all. He was just all of a sudden very ill. But nevertheless, she went to jail that same night. And then she waited for a few months. The trial was held. And in court, 6 different physicians testified saying that nothing else could have caused these symptoms other than shaking, and therefore she was guilty of child abuse. So Trudy was convicted, and she is now in prison serving a sentence of 10.5 years. So I bring up this case because it's a very kind of typical case of Shaken Baby Syndrome. Several of these cases have come up in the news. They're very common, or not super common, but they're common in the US, and they're starting to be more common in the UK and in Australia and some other European countries. So just to close that up, there are over 1,000 people in prison today in the United States for convictions related to this, Shaken Baby Syndrome. So what I was interested in is this controversy, which is about can you really tell whether a child was shaken just by these certain clinical findings? And my goal as a statistician was, okay, I want to figure out what kinds of arguments are being made in the research and in court about shaken baby syndrome, and I want to see if they're correct, if they're made properly, and if not, how could we make them better? And so, as I said, I'm going to talk about these two serious problems, and I'm going to provide some solutions that I think are important. Okay, so first I'll mention a little bit about shaken baby syndrome. The three images at the top, these are the triad of symptoms. So,
You're shaking a baby.
okay. So, I think Amelia's perfectly fine. Okay, so in before 1971, shaken baby syndrome didn't exist. That's the year when a British neurosurgeon, he's been called one of the first pediatric neurosurgeons in the world. He wrote a paper and he hypothesized that some of the children he was seeing who had this triad of injuries, the parents who brought the children in, they said, oh, you know, I give my child a little shake when he's crying a lot. Because at that time it wasn't stigmatized to say, you know, I shake my baby a little bit to make him calm down or stop crying. So Norman Gutkelch said, well, maybe the shaking is what's causing the symptoms. And then it wasn't until 21 years later that the triad was actually used to start convicting individuals. And then since then, many convictions have been made, and in fact, there have been exonerations as well. So the Innocence Project, on their website, they show there have been 15 exonerations that are directly related to cases of shaken baby syndrome. So these many convictions and then few exonerations, they've started this controversy, and it's included the CDC, the Centers for Disease Control and Protection, which is sort of like the medical authority in the United States, as well as the American Academy of Pediatrics. And there are many physicians and attorneys and other researchers who are involved in this conflict, in this controversy. So I just cited here the CDC's definition of shaken baby syndrome, just basically a brain injury that is caused by impact and violent shaking. So it's inflicted by an adult, and you get these brain injuries. Okay, so I want to talk about the statistical problems that I see with the research by mentioning a specific paper by Sabine Maguire and her co-authors. So Maguire is a physician and researcher at Cardiff University in Wales. So she and her colleagues, they said, okay, we have this big controversy about whether you can really tell if a child was abused or not just by these clinical symptoms. So why don't we make a statistical model that we can use to take, input these symptoms, and then that it outputs whether the child was abused or not. That would make it a lot more objective and a lot easier for a physician to determine whether this was shaken baby syndrome or some kind of accident or a different kind of cause. And so the authors suggest, okay, this is great, we can, if you have a new child who needs a diagnosis in the emergency room, you can just use this tool. And this is the cutout of the paper. So they use a logistic regression, and this has been cited many times, and it's been discussed extensively in the shaken baby syndrome controversy. So the data that they used to fit their model is proprietary data. So they contacted the authors of different studies who had, they've gathered data and they had done sort of similar analyses, but they collected a few. They got 6 data sets, and they all have information about children who are under age 3 and have brain injuries. There are 1,053 children in their database, and 348 of them were marked as abused. Many of the variables have a high proportion of missing data. So for instance, one of the 6 data sets the variable retinal hemorrhage has 80% missing values, and that's maybe the extreme of how bad it can get, but there are a lot of missing values overall. And yeah.
Sorry, where the word abuse is used, does that refer simply to an act which amounted to shaking, or does it refer to deliberate intention to distress or injure?
Abuse it implies intention.
Right.
Okay, so the data set that they use, it has several variables. The main one, which is the outcome variable, is this one, abuse, and we just talked about it. There's no missing values in that one. There are no missing values. Then there's things, the clinical features, retinal hemorrhage, rib fracture, long bone fracture, and a few others. So there are a few statistical problems with this model, and so I split them up, minor and major. So the minor problems, they're things that you would talk about in a sort of a regression class to statistics students. You would say, okay, you know, you have like sample selection bias. The data sets that you used to fit this model were coming from very specific physicians, and so you don't have a random sample. It's maybe not representative of the population. It assumes that the missing values are missing at random. So for instance, if you have long bone fracture, if you have a missing value in that variable, it doesn't seem like it's missing at random. It might be that the child just didn't have a long bone fracture, and therefore the physician didn't write that in. So, and also it makes it does model selection using p-values, and it combines data in kind of a strange way. So there are a few problems that we would talk about statistically. But there are a few others that I call the major problems, and these are the ones I think are a lot deeper. So the first one is that I think the authors are asking the wrong causal question, and then the second is that the outcome variable is biased. Okay. So in the first problem, I want to state 3 tasks that we could use, that we could perform, and in forms of questions, and they're called forecasting, backcasting, and attribution. So for forecasting, the question is, if a child were to be shaken, what's the probability that the child is going to have the triad of injuries? And this is the kind of question you might ask in science. You might run a randomized control trial, if you could, and you would get some idea of this probability of causation. Now backcasting, it's doing sort of the backwards version of that, which is, say that this child has the triad of injuries, what's the probability that the child was shaken? Right? Now, there's a third task, which is a little bit more unusual, and I think Phil and Steve and a few others have mentioned for a long time, but there's not a huge literature about it. And this question is, okay, this specific child was shaken, and he got the triad of injuries. How likely is it that the shaking and not an accident or not underlying medical condition, not anything else, caused the triad of injuries? So I think the first time you see these 3 tasks, you might think the second 2, the backcasting and attribution, are maybe the same thing, or it's hard to tell why they're different. So I can point out 2 things now, but I do think it took me a little bit of time to just understand why they're different. But the first point is that attribution deals with a specific individual and not a population. And then the second point is that in attribution, we already have observed that the child was shaken. And so, for instance, the attribution is used a lot in cases where, for instance, you have a woman who got lung cancer, and she's claiming that using some brand of cigarettes for many, many years, that's what caused the lung cancer. And so in that case, we would say, well, we've already observed the woman got lung cancer and that she used the cigarettes. So we're not interested in asking how likely is it that she used cigarettes, right? we're interested in saying, how can we attribute, right, what's the probability that we can attribute that the lung cancer was caused by the cigarettes, and in this case, that the triad of injuries was caused by shaking. So I'm going to introduce a little bit of notation for the causes of effects framework. So I guess I should have mentioned that. So the forecasting and backcasting are often called effects of causes, and attribution is called causes of effects. So a little bit, it's not, no, you don't have to remember that, but that's the difference. So we have this top table is just telling you what are the random variables that you could use to calculate the probabilities of causation. And so, and I said, what does it mean when the variable equals 0, and what does it mean when it equals 1? So E stands for exposure, so in this case would be to shaking. So it equals 0 when the child is not exposed to shaking, and it equals 1 when he is. Response is it equal to 0 when the child does not get the triad of injuries, and it equals to 1 when the child does get the triad of injuries. And now these two potential responses, these are specific to causes of effects, and what they mean is you have R sub E. So R sub 0 is the potential response when the exposure is 0. So R sub 0 equals 0 when the child does not get the injuries when he's not shaken. And it equals to 1 when the child gets the injuries when he's not shaken. R1 is 0 when the child doesn't get the injuries when he is shaken, and it's 1 when the child gets the injuries when he is shaken. Okay, so after that, we can actually look at the different probabilities of causation for the two different kinds of questions. So the first one is the effects of causes, which includes forecasting and backcasting. For that, what we would be interested in calculating is what's the probability that, given that the child was shaken, the child had the triad of injuries. And the second one, which is backcasting, is given that the child had the triad of injuries, how likely is it that she was shaken? And there are a few other ways to calculate these probabilities of causation, but that's the general idea. For the attribution case, it's a little bit trickier. So in this case, we have P sub C, which... Uh-oh. Well, you definitely need to see that. I'm not going to try to...
Check the cable.
Shaken computer syndrome.
I was not
There must be the cable there.
Shake it.
Oh, I think now the black screen is working. Maybe not. Yeah, I think it is.
Keep walking.
All right. I'm not going to let you go until this is fixed. Trap you. Okay, I think it works now. Okay, so this last formula, it's P sub C, which means that this is a specific probability for the child, and it is the question of, given that the child got the injuries when he was shaken, and he was shaken, then what's the probability that he wouldn't have gotten the injuries if he weren't shaken? Okay. So in order to digest this a little bit, I made a sort of fictional example. So if, for the sake of argument, someone were to run a randomized control trial, then say that we got that the triad rate, so who got the triad and who didn't, for the randomized control trial were, if the child was not shaken, 12% of them got the triad, and if the child was shaken, 30% of them got the triad. Let's just pretend that that's how it worked. So in order to fill out this table, which you would then use to calculate the probability of causation, we need to fill out the margins first. And that's a little bit different than something you might have seen with effects of causes. And I also have a slide for effects of causes if anyone wants to see the contrast towards the end, but we don't have to see that. So, since the child was not, when he was not shaken, he got the triad, then that's going to fit in under that spot, right? R0 equals 1. So that's 12%. And we know that that bottom row has to add up to 100, so the other one's going to be 88%. Now, on the last column, we have that when the child was shaken, he got the triad. So that's going to be R1 equals 1. And again, we have to add it up so that it gets to 100, so the other value is going to be 70. Now, the probability of causation that I mentioned before is this value. So for R1 equals 1, we sort of look at that row, the R1 equals 1 row. And what we're interested in there is the R0 equals 0 column. So we're interested in that X value divided over the total in its row. So in order to fill in the inside of the table, we just call that X, and then, you know, that column has to add up to 100, so the top value is going to be 88 minus X. And then that row has to add up to 100, and so on. So that's how you fill in the inside of the table. After you've done that, then you can calculate this value, and you get its X over 30. What you can also see from the table is that you have this bound on your X that cannot be, it has to be greater than 18 and less than 30. And so, and that's because the counts have to be between 0 and 100 in your table. So that's why you have that bound. Then if you combine these first two rows, you can get that the probability of causation in this case is greater than 60%. Okay, so this is all to say, look, I think what the McGuire and co-authors and a few other papers have done is that they're asking the wrong questions. I think they're asking the question about backcasting, which is, you know, what's the probability the child was shaken given all this information? And I think they should be doing attribution, because that's what they're going to need to do when you're a physician, you get a new child in the emergency room. You're looking at one specific child, and you're assuming, you know, the damage has already happened. What can we do now to figure out if the shaking or this abuse is what caused the injuries?
How do you know if there was an abuse?
So how do you know if there was an abuse? You don't know. So you're saying, say that this child was shaken. How likely is it that this caused the injuries? If you shake a child and nothing happens, then that's not abuse, that's not a crime. So we're only interested in the cases where if the child were shaken and that caused the abuse, those are the cases we're interested in. That's the worst case scenario.
Are you making an assumption that when you say the child was shaken, that this happened just before the trauma that sent him to the hospital?
The way physicians, so the way these cases have worked, yeah, that's correct. So there's a paper by Mary Case, I think it's from 2012, and it says that when there is some kind of shaking, violent shaking of a child, the injuries are caused almost immediately. And so whoever noticed that the child was ill, that's the person who must have abused the child.
So I don't understand. Sorry, I don't understand.
Because of the physical
the child
mechanism.
Was shaken.
Yeah.
The symptoms happen immediately. The child's taken to the hospital, and you're asking if something else could have caused the injuries? Yeah.
Yes. Well, for instance, what about the baby falling from a table?
Yeah. And being shaken, both? Bad day?
No, I'm just saying, say that there was an accident. You know, you set the baby on the table, the baby rolled over and fell and got the triad of injuries. That was an accident. That was not violent shaking.
Of course, but you said we assume the baby was shaken.
Well, in the worst case scenario, we're trying to figure out, say that this is what happened. Say that the baby was shaken. How likely is it that that's what caused the triad of injuries? If you're interested in asking the question, say that the child fell, how likely is it that that caused the triad of injuries? You can also ask that kind of question.
Yeah, but sorry,
But yeah.
even shaking, I don't see the crime. If there's not the famous mens rea, you do in portals. I've seen children shaking just because they were crying or something like that.
So the question is,
Go
right.
to prison for that.
Right. So the question is, how could you tell that there was the intention to commit child abuse when there's some shaking? What if you were just shaking the child, you know, just to pick him up and shake him a little bit, you're having fun, you're whatever, it's like a normal, non-abusive activity. So I know in the United States, and it's starting in the UK, when you have a child in a hospital, they give you brochures and they give you a lot of information about how shaking causes shaken baby syndrome. And so they're trying to make sure that everyone is aware that this is a form of child abuse. And so therefore, you can't just claim, oh, you know, I was just shaking the baby. And they say, no, you should have known that that can cause terrible injuries, and therefore you can't have done it without intention. Yeah.
You are now defining a situation in which, by law, shaking a baby is abuse. Because it risks.
Only if you have.
Because you've been handed a leaflet which says you risk injuring the baby if you shake it. Therefore, if you shake it, by law you are abusing it. It is taking the discretion of inference out of the situation.
Right. So the question was, I'm assuming that shaking by law, that shaking a child implies the intention to abuse. And what's the question? Why do I do that, or?
I think we should maybe move on.
Okay, so that's not my idea. I mean, I think what I've done is read a lot of the trials, the records from the trials, and this is the kind of argument that is made every single time. So I'm just repeating that. I don't necessarily think it's correct or incorrect.
Can I ask one more question? Because I really don't understand what you're getting at in the sense that you say we know the baby was shaken. But are you saying it's possible the baby was just shaken very gently and had nothing to do with what we call shaking?
So
the person says, I shook the baby, but they don't mean they shook the baby. They just mean they did this.
Right. So the question is, how much shaking do you really need? And you're asking, what do you mean by this kind of
the baby
shaking?
was shaken hard. And
So what I'm saying, just to close really briefly, what I've seen in these cases is that there's a wide variety of the types of shaking that have caused convictions, and some of them, at first in the early days, they would define it as very violent shaking, and so they even have, in court trials, they'll have a doll, and the prosecuting attorney or the expert witness will shake this child very violently. So if you look it up on YouTube, you will find those kinds of videos. Later on, they started saying, you know, this could happen with a very mild shake as well. And so they're broadening the definition so that more people end up falling into this bin of abuse. And that, I'm just sort of repeating what I've seen happen in the court. Okay, so moving on. It's possible to calculate this probability of causation of causes of effects by using the effects of causes kinds of experiments like I was showing before. But in this case, of course, we can't perform an experiment. You can't just go around and shake some babies and not shake the others and figure out what was the difference between them. So I think that you just can't do that. But there are some researchers who have done other kinds of experiments that could simulate the forces. So there are computer simulations, there are dolls with force sensors in the head that could tell you, what's the force that you would need to shake this baby with, so that the brain membranes would tear at the right amount, so that to cause the triad of injuries. They have performed experiments with pigs and with babies who have passed away very recently. So there are ways to get close to this, but all you can really get in a causes of effects analysis is an interval. So really the best case scenario is, does 0 fall into your interval or does it not? I'm not claiming that physicians or attorneys should do this in court. I don't think they should sit down and calculate the probabilities or something. I just want to make sure that people understand that the kinds of questions that they're making and the kinds of answers they're giving are not specific to, or they don't really match up. That's what I'm trying to say. Okay. So moving on to the second problem, this is totally different. And that's the question of the variable, the outcome variable of abuse in the data that they're using. So abuse was never observed directly, especially by the researchers or the physicians doing this, the analysis. So if abuse was marked as positive, then it was either confirmed in court, admitted by the person who was accused, or an interdisciplinary team confirmed that it was abuse. And there are a few others, but they're kind of similar to these. So the problem here is that we don't have a gold standard. We never observed whether the child was abused. And so there are some problems with that. And two of the problems that have come out of it are, there's a circularity because the outcome is determined by the clinical features. And I'll talk a little bit more about this later. And then also there's other kinds of bias. So for instance, there have been false or coerced confessions. There have been interrogations that provide leading questions so that they'll ask you very directly, I know you shook the baby, why did you do it? Before you even say what you were doing. And there's also this question of you have expert witnesses, and whatever they're saying is going to strongly influence the jury, so it's that outcome variable being defined as abuse it suffers from any kind of bias coming from all those processes. So how could we eliminate this kind of error, the circularity or the bias? So this is where I talk about, this is cut off, Bill Thompson's work. So the National Commission on Forensic Science in the US, they recently published an article about this question of task relevant and task irrelevant information. So the simplest example that I like to think about is if you have a fingerprint examiner and he's supposed to say, do these two prints match? Then he doesn't necessarily have to know about what the race of the suspect was, or how the age, or what were the circumstances of the case, or any of that. He only needs to know what are the two prints, right? Maybe he needs to know what's the material that the print was taken from, what's the distortion on the surface, things that are relevant to that kind of question, but not anything that could bias the forensic analyst's result. And so the National Commission suggests, let's remove the contextual evidence when doing this kind of forensic analysis. But in shaken baby syndrome, it's a lot more complicated than that. So in shaken baby syndrome, we have two individuals who often make the decision of whether this was abuse or not, or shaken baby syndrome or not. It's the physician, and then if the child has died, it's the medical examiner. And many of the children who have shaken baby syndrome do die. I can't tell you what the proportions are because the data are not very good, but I'm aware that many of them do die. So for a medical examiner, you have these two tasks that the examiner has to perform. One is to decide the cause of death, and the other is the manner of death. So the cause of death is like the physical mechanism by which the person died. So for instance, it's had a bullet wound through the head. Now, the manner of death is, why did that happen? Was that a suicide? Was it an accident? Did someone commit the murder? What were the circumstances? Where was the person? Things like that. The physician actually does something very similar. It might not be called cause and manner of disease, but there are diagnoses and external causes that they have to enter into the computer once they've seen the patient. So there's this thing called the ICD-9 codes, the International Classification of Diseases codes, and they have various iterations of them, 9, 10. And so anytime in the United States, and it's also used internationally, but I've seen the databases from the US, anytime a physician sees a patient, they have to decide what's the principal diagnosis. Up to 25 secondary diagnoses and then external causes. So the diagnosis would be like the cause of acquiring the disease, and then the external causes are, what were the circumstances that the child was in. But both cause and manner are decided by the same individual, so you only have one physician, one medical examiner. So there are a few problems with this. The first one is that it's very difficult to forget contextual information once you've heard it. And so you can say, I'm going to try really hard to ignore all the contextual information and make my decision completely in an unbiased way. But that's been shown to be very difficult. And the physician often talks to the medical examiner and tells him or her his opinion or her opinion. So there's even more bias going on in this kind of chain of information. But this is the problem I haven't heard much talk about, which is that in shaken baby syndrome, both the diagnosis and the external causes are conflating the cause and manner in which the disease or the death was acquired. So you can't really separate the contextual evidence in this case, in shaken baby syndrome. So I just remind you, the CDC definition of shaken baby syndrome is that you have this injury to the head, but it was caused by this impact or violent shaking by an adult. So a solution to this kind of contextual bias could be, okay, we could do blinding, right? We could remove the contextual evidence, and then that way we can help remove the bias from whoever decides the cause of death, manner of death, diagnosis. First, the physicians shouldn't be speaking to the medical examiner. That's one way to stop the chain of information. And also, I suggest that there should be separate tasks, that there should be actually 4 people making this decision. There should be 2 doctors, one for diagnosis and then one for the external causes. So once the doctor who makes the diagnosis has figured out the diagnosis, then he could communicate or she could communicate with the other one, but not the other way around. Or it could be the same person, but they should be only aware of the right information at the right time. And there should be 2 medical examiners, again, one for each type of information. And in addition, we need to change the name of shaken baby syndrome so that it doesn't include the manner by which it occurred. Otherwise, we just can't remove the bias. So the author of the 1971 paper that I talked about earlier, in 2012, he wrote a new paper revising his views from 1971, and he said, we need to change the name of shaken baby syndrome. He also suggested this kind of deep change, and he said we should call it infant retinodural hemorrhage with minimal external injury. So, I'm not saying you should understand what this means. I'm just saying this is just the physical mechanism that you're observing. It's not indicating how did it happen, why did it happen, what was the intention of the person, and so on. So what I intend to do in my dissertation is I want to get a better understanding of the biases and the errors that we get in the data, just like the type of data I showed at the beginning. I want to see how to communicate these kinds of ideas to doctors and lawyers in a way that is clear and they can understand it and it makes sense and it's not just, statistics. So that, or it's not just something that they dismiss because it's too philosophical or something like that. And then I also want to use the causes of effects framework to analyze shaken baby syndrome data, maybe with these simulations or something similar. So I circled the first one because that's what I've been thinking about recently. And okay, so I'll go through this really quickly. It's a Bayes net that I made about the data in shaken baby syndrome. So we start out with 3 latent variables, and these are the different things that could have happened to the child. Either the child was abused, or the child had an accident, or maybe there's some other medical condition that's been causing the injuries. Now, these cause different clinical features, things like retinal hemorrhage, cerebral edema, subdural hemorrhage, something else. And I don't know exactly how these arrows are connected. This was just sort of a, as brainstorming. They're connected in some way to these 4 things. For accidents, even if you have the triad of symptoms, say, or the triad and something else, or a combination of things, if the accident has been witnessed, then it gets marked as a signed accident. And this is what actually has happened with the data. This is I'm just writing this as a model of how the data have been generated. If we combine a few of these, maybe we have a different medical diagnosis that we recognize, and so we can assign that one. Oh, maybe this was vitamin D deficiency, something like that. And for abuse, it's a little bit trickier. So what they've done is they've combined information from these clinical features and used the criteria to say, oh, this was the abuse was confirmed by the court, or it was the person who did it admitted that they did it, things like that. And then that gets written as abuse. So I wrote it as assigned abuse, they just write it as abuse. And the other, this would be great if we could see this, is when we actually witness the abuse, right? And then in that case, you would just go directly to assigned abuse. But I've never seen a case of witnessed shaking and then the triad of injuries. I've seen instances of the triad of injuries, and I've seen instances of shaking. If you look up on YouTube as well, tons of babies being shaken, no injuries. So this is the model I'm thinking about for analyzing the data, and then I'll think about, well, what are the errors that come into each one of these measurement errors? There's contextual bias, things like that. And so that's sort of my next step that I'll be working on in my research. Okay, thanks so much.
Questions? So we'll start here, so then we might go back to it.
If you could go back to the last. So first, possibly you're an anti-inference bias, because you assume that if you have a witness, then case closed, whereas we often know that eyewitness is as problematic or even more problematic than other types of evidence.
So you're talking about even this piece
Yes.
would have this kind of bias?
Both witnesses, maybe problematic.
Yes.
Then there's an issue that you might wish or wish not to get into, and there is a social background to the entire story.
Yeah.
Because it is usually not rich women who are accused of this
Sally
abuse.
Clark.
That's right.
Sally Clark.
Wasn't
No,
shaken.
shaken baby syndrome tends to be
No, but you said it's usually not the rich women who are accused.
right. So what's happened is most of the victims, or most of the people accused, have been, in the U.S. at least, young black male. But the cases that have been in the media have been young white female. So that at least gives visibility to the.
And none of them was one who could afford hiring a caregiver while she's doing her PhD.
Mm-hmm.
So there might be social
Yes.
backgrounds that contribute to the biases that you might find.
Great.
Because usually none of the judges is either young white women or a black.
Young male. Yeah. Great. Thank you so much. Yeah. Yes.
Oh, I don't mind.
You go ahead.
Julia, go on.
No, just you said that all that started in the 70s. It didn't exist before. It was not reported. What
No.
happened to humankind? What happens? For example, I'm very curious. Seriously. For example, to China, India, you have a lot of statistics there. What is going on? I don't know. Perhaps it would be a different cause. What we eat, what we, I don't know, something else, and then a little shake is enough to break everything. Everything is possible. No.
So the question is, why all of a sudden did we have shaken baby syndrome, and why only in the U.S.? What has happened in other places? So before, why didn't it? So I think the reason it caught on like a wildfire is that this triad of symptoms is seen often, not extremely often, but you do see it in emergency rooms, especially in children's hospitals. It comes as in this in this triad, right? And you see it all the time, and you have no other explanation for it. So SIDS is that way, right? With Sally Clark, you have, oh, no explanation, so what can we do about this? Like, we want to have some culprit, like who did this to this child, so that it was a healthy child and all of a sudden it's an ill child and maybe he died. And so I think it's caught on because it's something that people, you need an answer to why this child is so sick. And so I think it's caught on, and it has started to catch on in many other, in the UK it's pretty big, Australia it's pretty big, in Colombia it's just started, but it has different translations from English, so it's not unified yet. But my impression is that it's all going to explode pretty soon, yeah.
Joe, we're going to have just a couple more. Joe.
I'm wondering how come they haven't done a case control study like they did with Rye syndrome, which is also a rare effect. In other words, you could have this in children's hospitals, which would get this type of case. You could match them to a case of a similar another neurological patient, and kind of look back and then interview the parents, and sometimes even go back to the scene if you did it fast enough.
Yeah.
And that would at least give you the relative risk.
Yes, yeah. So you were asking about why haven't people done case control studies about this? It's true that you can't do an experiment; it's unethical. But maybe a case control study could answer, what are the differences between the people who have it, the people who don't. So I actually tried to do that, but the data are very flawed. So it happens, for instance, that if there is a suspicion of abuse, the physicians will perform these tests, like looking at the retina, looking at the brain. If there's no suspicion, then they won't check.
But they could have a special case control study.
Oh, I see.
Which would do
check every child.
They would have they have these cases, of course, which present the triad. You try to have, I would suggest, a match study. A child coming into the ER with some kind of symptom that's neurological or something.
Got it.
And then you could see what's going on.
That's a great idea. Yeah, thanks.
So we only have a chance for one last question, but we can definitely ask Flores. I think you've given up. Okay, go on.
Hi, thanks for the insightful presentation. I just wanted to ask, you said that in the UK there are now many more cases of that, so many more cases of people accused and sentenced for doing this, or many more people shaking babies, or many more babies with the syndrome?
So so the question is what do I mean when I say it's more common in the UK now? All of those. I think it's all, like, there are more children diagnosed with the triad, more adults going to prison, and there's more research about it. There are more, for instance, in the UK, there's a physician called Wayne Squire, who was a skeptic of shaken baby syndrome, and she was an expert witness in several cases, and she said, I don't buy it. I don't buy that this child was abused. There's nothing to tell me that it was abuse. It's just these three conditions, but that's all we know. And I'm assuming, innocent until proven guilty. But I think the group of physicians who support but support the diagnosis worked very hard to discredit her, and now her license was removed. So she's not allowed to practice medicine after many, many years anymore. So it's a very contentious topic for everybody.
Okay, let's thank
Thanks so much.
Maria. It's really